we're all not saying anything. But hopefully more people will be joining us. I think we're up to about 14 participants now.
Well, good afternoon, everybody.
I still don't see Haley yet, or Nancy. None of you had problems getting on, did you?
No?
Okay.
Feels like usually people all come on in right around 1 or a little after, so.
Okay. Now we're up to 19. I just always look for the presenters to make sure that we have our people.
How are you doing, Paul? This is Armand from Tri-C.
Oh, hi, how you doing? Good to see you.
I'm good, sir. Good to see you.
Yeah, it's been a while.
Yes, been a while.
So how's your summer going?
Pretty busy. Working from home,
Yep,
but been pretty good.
good.
Oh, I see Nancy. I don't see Haley though yet.
Actually, Paula, it's Heidi.
Oh, it's Heidi. Oh, okay.
Right, yeah.
Hello, I know Heidi has got her stuff ready and is going to be on here. I talked to her this morning.
Great.
Well, we have Ohio State's presentation first, so. We're just going to wait maybe another minute or so, and then we'll get started. Just so everyone knows, we will have everybody on mute. And then if need be, you can go through the chat and ask your questions, or at the appropriate time, you can be unmuted and ask a question. We have asked people other than our presenters not to be on video, just so it's easier for some people, depending on where they're located, to be able to participate in the video, not the video, in the conference. And so I think, Zoe, we probably can have Paul get started. And we're very excited that you joined us today, and we thank you for joining us. I think Zoe's absolutely right. She said usually people start coming in around 1 or a little bit after 1. I see we're up to about 27 participants at this point. But Paul, why don't we go ahead and get started, and thank you.
Hey, thanks, Paula. Good afternoon, everybody. I'm Paul Sampson from Kent State, and until the summer, I am the chair of the Organic Chemistry Tag Group. And so what we're doing today is really a continuation of a discussion that many of you joined us for in the early summer, where we recognized that it would be beneficial for those people teaching organic chemistry around the state to exchange ideas about how best to proceed in this challenging COVID-19 era of remote education. And so what we're going to do today is to first of all have a couple of presentations. We have a group of 3 people, Christopher Callum, Christopher Haddad, and Noel Paul from Ohio State, who are going to tell us about the approaches that they're using for delivering Organic Chemistry Lab, which is perhaps the most challenging piece of everything that we face as organic faculty in teaching our courses. And then after that, Heidi Camel from Tri-C will be sharing the Tri-C approach that's been developed for teaching organic labs. So we'll start with those presentations, but then the bulk of the time, we're going to try to have a structured discussion. This can be steered either by whatever ideas you have or a few things that the presenters and I have talked about already that we can talk about in a little while. But anyway, let's get started by asking the folks from Ohio State to tell us a little bit about the approach that they're using for organic lab delivery. So Christopher's and Noel, do you guys want to take it away?
Okay, I think, well, welcome everyone. So Chris Callum and Noel Paul are actually the main drivers of this. They're the individuals responsible for teaching all of the thousands of students we teach in organic lecture as well as lab every semester. So Chris and Noel are going to lead off on this presentation. Go ahead, Chris.
Can everyone hear me?
Yes.
Okay.
Yes.
Thank you. Today we're just going to present some of the practices that we have thought about over the summer and implemented last spring. Sorry. So today we're going to talk a bit about the organic course laboratory overview at Ohio State. Just reminding some people about the digital lab experiences that we've created over the past years and we relied heavily on during this COVID-19 era. Then the second part of our talk today, we'll transition to just talk about some of the plans that we have for 2020, including some ideas on online assessment strategies, and then our hybrid approach to in-person and online labs. Just to share with you a little bit of background about the course structure, since everyone is a little bit different around the state. We have a separate course for the organic laboratories. We have laboratory 1 and 2, labeled 2540 and 2550. They have their own independent lecture every week that is 1 hour and 20 minutes, 4 hours of lab per week, and we average about 14 weeks of the semester in which we meet. About 88% of our population is co-enrolled in the first semester of organic chemistry lecture that has its own separate 3 hours a week lecture and 1 hour recitation. One thing that is unique to Ohio State is all spectroscopy is only discussed in a lab curriculum. Our population is significant. Usually in the autumn semester, we have about 1,500 people enrolled. And in other semesters, spring is a little bit down in numbers by about 40. And then we do about 260 to 300 people in the summer. Our building is located on campus, and our population primarily consists of pre-med, dentistry, and professional science students. We have physical, biological sciences, engineers, and we have about 3,000 people per semester. Celeste is going to undergo some renovations in the years to come. If you haven't been inside for a while, this is what it looks like. We're working on developing lab skills in our course. We primarily focus, as every lab course does, on techniques, data analysis, synthesis, purification, and structural analysis, as well as a focus on the theory behind chemical bonding and functional group reactivity. We hope to enhance our student problem solving and scientific reasoning abilities, and hopefully make a lasting impression on the chemical world and what it can do. In that lab lecture time, we have incorporated some digital pre and post lecture quizzes that we have built in-house. And I'll share with you guys some of those examples today. I'll also show you some of our digital pre and post labs that we've created that have worked well with us, as long as some of our ideas for digital lab reports and other molecular view and mechanism and literature topics that we discuss. And so I'll just briefly show you a few examples. In these digital pre and post-lecture quizzes that our students take before lab lecture, we focus on primary fundamentals for the class at the beginning, such as structure, bonding, and chemical representation, as well as understanding resonance and hybridization. We transition then in the second part of these quizzes to focus more on spectroscopy, highlighting infrared spectroscopy, mass spectrometry, and all aspects of nuclear magnetic resonance. Typical example could be something like this. Students typically could go through and do these problems a few times a week, and so this is an example of a mass spectrometry problem. We might ask them about splitting problems, and they vary in level of difficulty based on whether they are a pre or post-lecture question. And so the pre-lecture question, we usually get about 6 to 10 questions on one topic. They could be simple, and we have 2 choices where we're just trying to drive home fundamentals. In the post-lecture quiz, they're going to get more questions. They're going to get multiple topics. There's going to be more choices there to challenge the students to master the things that they have been shown. They do get unlimited attempts. Questions are marked wrong and correct answers are not revealed. And we built a substantial library of questions. So every time you go in to take it, you basically get a new quiz. But we have thought that these multiple low stakes assignments really promote mastery. They worked quite well for us in the transition during last spring to just keep the progress that we had already going. They have the advantage of instant feedback. Obviously, the students can go in and review them anytime. They highlight their knowledge gaps so that they can go and see where they're having fundamental mistakes and go and do other worksheets and problems to support that. They certainly motivate student performance to go out and get those points. And we think that they develop some mastery within this set. Other things that are digital initiatives that we built in-house that have been helpful to us. We do have a pre and post lab setup where we have built these in our own in-house. If we zoom in on a couple aspects of this, we can do things where we have a library of multiple choice questions that are pulled in for the students to choose from. Based on the experiment, they can go through and choose the correct answers. Usually at the beginning of the pre-lab, we try and focus on some technique and most importantly, safety. We have used the JSME editor. This is a free editor that you can embed, and it can grade not only single structures, but actually reaction equations. And so it can grade their knowledge of understanding a reaction equation. I'll show some examples of this in our assessment model later on. And then we can do random number generated stoichiometry problem solving. So the students can do a pre-lab table here electronically. They can get instant feedback on their calculations and have a chance to review their mistakes prior to coming to the lab space. We also have this set up for our post-lab system. Our post-labs take those experimental values from their lab notebook, and then the students will input their calculations for theoretical yield, theoretical mass and percent yield, and get instant feedback on whether those calculations were correct before they write their lab report. So they can have some practice and improvement in their stoichiometry skills through some of these digital assessments. Transitioning to some of our ideas for digital lab reports that have worked well in the past, we do try to focus on providing them with a template structure of a variety of questions where we go through and use ChemDraw as our primary drawing tool to teach students to use those tools that a scientist would use in our area of study. And students we try to transition our students to take that experimental observation, that macroscopic experience that they had, and try to represent the structures, the formulas, and the interactions between the molecules that are taking place. And so we're trying to use this chemical triangle from the education literature to link between the lab experience, between the symbolic and submicroscopic experiences that we have.
So Chris and I have had many conversations about the things that helped us really appreciate what the learning of chemistry is all about. And I love to cook. I'm sure most of you do. So much of what is done, or so much of the way that lab could exist, is just following a recipe and not being able to connect it. So we have very much invested in this idea of a molecular view, which is pretty much trying to create almost a crystal structure three-dimensional drawing just using line structure, but paring it down to be something that a student can do on a piece of paper or using one of these drawing tools. So for us, we really focus on intermolecular forces, as well as just molecular size and taking those things into account. And we admit that these drawings are fake when we teach, but we still think that they're very helpful. So one of the first experiments that we would do in a typical semester is a recrystallization of sulfanilamide. So we pull from the crystal structure database and model it, show them what the crystal structure of the single molecule looks like. We have it represented in some different ways. And then we turn around and show them the more complex view, like why is a molecular view necessary? Because a two-dimensional representation of a three-dimensional crystal structure, just at this point, in the third week or so of our learning, it's just completely lost in the mix. Some days I can't even see some of the more important interactions that are happening in a picture like this. So we can move from this to our molecular views. On the left, you see a repeating pattern with some significant hydrogen bond interaction between multiple copies of this molecule. And then on the right, we have two different iterations of a solvation model of sulfanilamide. So we propose these ways for students to communicate information about molecular structures. And then we challenge them, as Chris showed you in one of our examples, to recreate these from scratch. And I'll tell you, it is not a 100% success rate on these drawings. So it's a great way for us to really push students early to make them think about the structural aspects of chemistry that we have come to rely on in our own teaching. And then really quickly, there's an example shown here of a kind of more advanced question we would ask. This is definitely going to be for laboratory 2, where we have a reaction that honestly follows the rules we teach perfectly, but it is also something that allows our students to see a real example. We here have linked the OrgSyn prep for this process. We can ask students questions about what is buried inside of that OrgSyn prep, but really we're just having them recreate with a totally new set of reagents the type of mechanism that we know that they're capable of drawing. So then what we have been relying on for the past many years is this balance of pre and post lecture quizzes, pre and post labs, interfacing with our students using these digital techniques, getting deeply into constructing digital lab reports using ChemDraw. This past academic year, we also were totally fine with students using a tablet drawing, just because the access of tablets at OSU has been so much increase in the last couple of years. Focusing on this idea of what is actually happening during steps of an experiment, that is our molecular view approach, asking questions about these as well as mechanisms in literature. This is what we have as our springboard for moving forward to this very uncharted world of potentially entirely online laboratory experiences.
So for the second half of our presentation today, we're going to share with you just some of our ideas that we have for autumn semester. I'm going to highlight some ideas about our lecture or lab, our assessments, our in-person and online strategies, as well as some of the resources that we're creating to improve student engagement. For our lab lecture, we are planning to do asynchronous videos that will be posted. So we have broken the videos down into shorter segments based on the topics of discussion. We will discuss lab techniques, most importantly our theory, the different reactions that we cover, mechanism, and of course the spectroscopy content for our course. We're trying to keep those to 10 to 15 minute videos so that students can go in and find them by index and view them based on a weekly schedule that we will provide. Our lecture time, normally there are about 500 students in that lecture. We're going to use that lecture time for office hour breakout sessions, small group discussions, and problem solving. So we anticipate that we will poll the students perhaps in advance and go on and solve certain problems that they may be facing based on what the topics are that week. For our assessment strategies, this was one of the biggest stresses I think most faculty faced last year when we had to transition to online. Our traditional exam and quiz format included short answer questions, predictive products, mechanisms, calculations, and other representations of organic molecules. I think most of us are probably in that boat when we discuss how our exams are formatted. We try to make that format continuity possible by using the JSME editor that we showed you earlier, by embedding it into our Canvas-based questions, enabling our students to draw their answers and input a smile string structure so that we could grade that. The smile string is graded as a text answer, and since each structure has a unique smile string, we could also go back and scan them for mistakes and common inconsistencies in the structure. This technology provides us a nice continuity between something like a predictive product type question that students were used to when they took their exam on paper. We did have to create some videos to show students exactly how to do this. We even posted short practice assessments that they could go through and practice with the interface. What we did to create all these questions, we made a large question bank for the exam. And so Noel and I went through and identified the most important topics that met our learning objectives that we wanted to assess the student understanding on. We used our staff of TAs to write 5 or 10 questions per person. And then what we did is we went through and had everyone give us feedback. And so our staff went through all the questions and gave feedback on thoughts for improvement. Once we had that base of initial questions, we did go through and expanded them by writing variations. We altered parameters such as structure, reagent, starting conditions, and for calculations, we had random number generators inserted. And so with this enormous question bank that we created, we were hoping to reduce the opportunity for academic misconduct. I'm sure all of you found some of your question posted on Chegg at some point during the spring semester. We found some of ours as well, but the fact that no student in our entire course had the same exam, it diminished the opportunity. Like, I'm going to go search Chegg, you might not find the same question in time to get it. And so we're hoping to continue to use this question bank to expand it for future use, and we think it's one of the strengths of our system for online quizzing and midterms. So here are a couple of examples. This is a stoichiometry question where we had a random number generator in there, and students can go through and type their numerical answer for the theoretical mass. We could do simple GC calculations, giving dimensions on a chart paper, asking them simple questions about which one is a higher boiling point, which one has a lower boiling point, and such. We could ask questions about TLC. These are all the numerical questions. I think what most people are probably interested in, what I was talking about earlier, is using this. And so for the predictive product, we could embed this JSME editor in an iframe, and they could go through and draw the structure. And so the student would get this question at random. They could go through the JSME editor and draw the structure completely. If they hit that Get Smiles button below it, it will give them the smile string for that structure, and then they could copy and paste it into the answer box below, and it could be auto-graded. And so it was a nice workaround for us to be able to have an assessment for our students and have a large question bank that worked within that set. We also use that JSME editor for online assessment of like spectroscopy unknown questions. On the left side of my screen, you can see where we gave the students complete spectroscopy unknown. They have a mass spectrum, an IR, a set of values that correspond to their unknown, and then a proton and carbon data set. And so the students can work on the problem and then submit the answer into the JSME box. We also made questions that were very easy for us to randomize by using structures that had atoms that were numbered, and therefore we could write hundreds of questions very quickly just by asking about different atoms. And so you might think you have the same question, but we're asking you about a different atom. And so it allowed us very quick optimization and randomization of questions. And so in these two examples on the right side of the screen, we did a chemical shift estimate and a splitting pattern multiplicity prediction. And so our online assessment did allow us that randomization of testing. We really viewed that as essential to success if we're going to do these online exams in an unproctored environment. It is a significant undertaking to make that larger question bank and make sure everything is right. but we do think it helps reduce academic misconduct and helps students make better decisions. If you're interested in more about exactly how some of those JSME iframes were coded and some more details on this, our cohort from Ohio State has published a paper that just appeared in JChem Ed ASAP articles, and I can send this link out to the group if you want more information on that.
So definitely the thing that most of us are stressed about is what this social distancing is going to look like in a lab space. All of us at our different institutions have different kinds of problems. You know, there's no way around that. So the problems that I'm going to tell you our answers for are the ones that, you know, correspond to us having a floor of 6 rooms that could hold 20 people each. So at this point in time, we are going to operate at a 50% capacity maximum. That gives 100 square feet of social distancing to students in our ventilated lab spaces. In order to keep things organized, we're going to work on a bi-weekly rotation. So 20 students from a single section are going to distribute to 2 different lab rooms. That does make a lot of physical movement for the TA. So we want to engage some help for those TAs, which I'll talk about in a little bit. Following this week of in-class work, that same section is going to meet the following week in a digital way to work in groups together on an online experiment. And I'll describe both of those things. Oops, sorry. So here's our lovely 4th floor of Celeste Laboratory. Currently in a pre-pandemic model. We have 20 students each in 6 of those lab spaces. But in order to, you know, give us a lot more breathing room, we are reducing the density drastically, having 20 students in each of those sectors as shown. Normally, where we would have 4 seats in a hood row, we will physically remove the X'd seats so that only 2 people will exist per row, and 4 people total would be in one of those double rows. So we have chosen our list of experiments to hit multiple techniques all at the same time. I'll show you that list in just a minute. We're going to have workstations that have dedicated reagents and consumables. It'll honestly save our students a ton of time because they won't have to be walking around the lab constantly. And it also provides a huge amount of isolation so that students are not touching the same bottles as their other 10 peers in that class. We're going to have a directional flow marked out on the floor just to help keep that crossing to a minimum. And then we're going to provide disposable face masks as well as gloves and goggles. And then this will also be the first time that our department has implemented lab coats for the organic section. So I mentioned previously, at each time slot between those 2 rooms, we're going to have a TA and a head TA. They're going to team up and circulate through both rooms, do the job that a TA does. The section TAs will be the point person, of course, but our head TAs is something that we have developed this model over the last, 8 years, I guess, since the switch to semesters. So these are our experienced TAs, either graduate students that are quite far along in the program, or teaching assistants that we hire outside of the undergraduate system. But we do hire a number of undergraduate TAs as well. We're really happy to have this head TA as a resource just to help our first-time TAs who are not going to have the kind of support that we are used to giving them with a floor full of people. So the experiments that we're going to conduct in person, we're going to cover the range of extraction, recrystallization, several types of chromatography and distillation. We'll do 1 synthetic experiment in OChem 1. In OChem 2, we're going to cover electrophilic aromatic substitution, everyone's favorite. We've got cyclization to form a quinoxylene ring system. We have to do a Fischer esterification because we're organic chemists, come on. And then the Diels-Alder reaction of Benzyme, which is also another one of my favorites for a lot of reasons. we went through and probed really closely the different tag numbers that are associated with this. And I can tell you, well, first off, I chuckle because number 2 is acid-base chemistry. And as far as I'm concerned, that's important every minute of every experiment. You'll see the higher numbers, 20, 22, 23. These are the ones that correspond to the different techniques, lab skills, lab notebook skills, safety awareness. So I think we have a pretty solid coverage of those physical requirements. So then the online experiment is going to look a little different. We have been working with our teaching team the entire summer and with our Arts and Sciences College Tech team to make these 10-minute edited videos that are an entire experiment. Students will be able to watch these videos, and really they can watch these videos whether they're going to perform an experiment for real. We've made all of the experiments into video form. Or they will not perform the experiment, they'll simply just watch the video and glean what they can. During these weeks, there'll be no in-person experiment for their students, but they will meet with their teaching assistant. This is a part that we really want to emphasize. They can work through these videos. We'll have some data embedded in there for students to do calculations. But the most important thing, and we've heard this from our administrators and from our leadership, like, oh, we're all online now. Oh, that means that one person can teach 1,000 students in a Zoom room. And from the very onset of this, we have agreed that we feel like the total opposite is true. By homogenizing everything into a screen, you take that ability to have a relationship with somebody and you dilute it down to a factor of just, population statistics. So what our vision for the online lab really is to have a very small group of that section meet for a short amount of time. So their TA and a group of 4 or 5 students will get together and they will work through a worksheet, some Q&A that deals with these online videos that they have just watched. We want to emphasize in this small group environment the mentorship that you actually get in person when you work with your teacher or your TA in a lab experience. And it does mean that the TAs are going to have to perform the same experience, 4 times per class probably. But we have to pick something to focus on. The online experiments that we have prepared different testing materials for, again, recrystallization and chromatography as a way to highlight those components, different spectroscopy methodology. We'll do a Grignard digital experiment, and then a few more synthesis experiments for Lab 2. Again, we have taken time to note the tag guidelines for these experiments. Of course, the 20s are going to be absent because we are not going to be meeting in person and practicing lab techniques ourselves, but we will have plenty of exposure to spectroscopy and data analysis, as well as all of the fundamental mechanistic chemistry that we can agree is really important to learn. So we hope that this 50% model of in-person and online will allow us to achieve these learning objectives, being socially distant and responsible, but still trying to make a connection with our students, which we value so greatly. We know that creating buy-in is going to be the challenge of this entire experience. Along with that buy-in, I think flexibility is a huge thing too. We would be foolhardy to set up some impossibly rigid framework and then, never look back. We have to be flexible, so we have a lot of ideas that these videos and other resources can help us implement if people are sick for a day or a week, or hopefully not much longer. Looking forward, we think that the electronic testing protocols are really the thing that we have learned the most this year, and improving those resources, learning how to do this better, and then refining our approach to the experience that we give our students, and of course, helping our staff to be as good as they can possibly be. A lot of energy has to go into this, so our hopes are high. It's a good starting place. So, of course, we have to thank our department. Professor Turo is our department chair right now. She has been amazing throughout this process. She's really facilitated a ton of the things that we've needed to even hope at having success in these pretty hectic times. Terry Gustafson is our Vice Chair of Undergrad Studies. We'd like to thank the ACS Technology team. We'd like to thank Dr. Spinney, Rick Spinney. He is the man who figured out the JSME embedded thing in Canvas. So we cannot thank him enough. He has really empowered us to take on a very high level of structural question and analysis with our students. Our chemical stockroom manager for the last 8 years has been one of the 3 people shown, Brent Sonner, Eric Houchin, and Zach Reaver. And of course, our amazing teaching assistants are the only thing that keep us afloat. Thank you very much. I'm really happy to be here to give you whatever hints and tricks or whatever we can offer. I think we're all sweating bullets moving into the next month. But thank you very much for your time.
Thank you.
Thanks, Noel. Thanks, Chris. That was great. So some really good insights there. Maybe if we just spend a couple of minutes, if people have a burning question for you guys, maybe they could ask it now. Otherwise, we'll go to Heidi, and then we'll come back for a much more sort of in-depth discussion after Heidi's finished with her presentation. So did anybody have a burning question that can't wait for 15 minutes? Okay, so why don't we move on then? And so Heidi, do you have your slides? Yeah.
There we go.
Okay.
Hi.
Great. So if you'd like to sort of share with us then what the plans are and what you've been doing at Tri-C.
Sure. Well, thank you for the opportunity, and it's my pleasure to be here. And I've already learned a lot from the presentation. I took a slightly different approach to this. I have a much shorter and more concise, and I wanted to share with the group the lessons we learned from teaching organic chemistry in the spring and summer, what worked and what didn't work, and the big picture on what we're going to do in the fall. So I don't have a lot of details exactly, but I'll share with you what worked for us and what we'd like to do in the fall. I also work closely with Nancy, my colleague. I'm very grateful. She's at the West Campus, and we have conversations pretty much almost every day lately, and we're working together on planning our organic chemistry courses in the fall. So just to give you an idea, we're very different than Ohio State. We are very small. We're a community college in Northeast Ohio. We typically offer 2 to 3 sections pre-COVID-19 of each organic chemistry. So 2 to 3 sections of OChem 1 and 2 to 3 sections of OChem 2. And this fall, we'll only have 2 sections of each that are on the schedule right now, and we hope that they run. The number of students per section pre-COVID is 24. Post-COVID is also 24, but the labs are slightly different, as I'm going to share with you. So in the spring, I taught Organic Chemistry 1 with a total number of students of 12. So I'm pretty lucky and fortunate to have such a small group of students. And prior to all going to the remote instruction, I had very strong relationship with the students. They all also built relationship with each other as we spend a lot of time together. So I'm going to move on to the next slide. And so in the spring, I used a combination of both synchronous and asynchronous activities. And I found that the combination of both were very effective for active learning and also increasing student engagement. So in terms of synchronous, I held Zoom meeting sessions during the normal class schedule. We met on Tuesday and Thursday from 9 to 10:15 or 10:30. So I held these synchronous Zoom meeting session at the same time. I had a very high attendance, and students shared with me that they found value in attending these synchronous sessions. It helped them with their structure every day. It helped them with a sense of community, and so they asked me to keep doing it. Not everybody was able to attend, of course, these sessions because of class or their work schedule, changing work schedule and time issues, and also a few of them had technological problems. And for this reason, I recorded all the lecture videos and shared it with the students. So the recorded lectures represents the asynchronous learning. Now for my Zoom meetings, I use my iPad, and I use the whiteboard feature on Zoom. And I also use an Apple Pencil, and it works really well. You can see a screenshot of what the video looked like using the Apple Pencil. It's very smooth. If you don't have an Apple Pencil, you could still use the screen share and the pen tool on PowerPoint. I don't typically use PowerPoint slides when I teach organic chemistry. I always draw, and so that's why I like the whiteboard feature on Zoom. I think there is a very similar feature on WebEx, but I hear it's a little bit clunky. You can see also in that little screenshot that that it's captioned. There are captions there, and this provides a resolution to our students who have accessibility issues. So this is how I did the lecture in the spring. I plan to continue the same thing in the fall. We're also going to have synchronous meeting sessions during the class schedules that are published online. And I also plan to record the lecture videos for those students who have issues with technology or time constraints. Next slide, please. Okay, so for the lab component, in the spring, when we transitioned to remote learning, I designed every lab to have 3 components, a read, watch, and complete. I called it RWC. For the read part, the students were required to read the lab manual to be prepared for the lab, just like they are going to doing the lab experiment. They were asked to review the background and the theory and familiarize themselves with the protocol in each lab. And students were held accountable for that by answering a number of pre-lab questions. Some of them were regarding the safety, and some were based on the theory behind the actual experiment. And then the second component, students were watching videos. We didn't have time to record videos. We don't have TAs at Tri-C. So I found a lot of YouTube videos that I could use. Not everyone was good, but some were inaccurate. Some were very old and had mistakes, but I used all of that to my advantage and made them interactive. So I put the link, and you can see here a screenshot of my Blackboard with the 3 different components. This is not for you to read, it's just to see how I put it together. So in the watch, there's that link to the video, the YouTube video. And again, some of those videos were not accurate. So what I've done is that I would frame questions regarding the video. So for example, if the chemist or the student in the video made an error in the workup for the experiment, then I would say that the student made a mistake. Identify the mistake that the student did, how it affected the result of this experiment, and what should you do. If there is a slight change or something different in the video, in the YouTube video, than the procedure or the protocol in the lab, then I'll ask them what is different. And how does that affect the procedure overall? So it's sort of like very basic interaction with the video rather than just watching it passively. They would actually pay attention. And then the last part of the lab, of each lab session, is to complete. And complete, it varied depending on the experiment. In some cases, I had raw data collected from previous semesters that I shared with them and asked them to complete the lab report using that raw data. And some other times I didn't have raw data, and I provided them with critical thinking questions from the lab manual, actually. And the lab manual that we use is the Schafstall lab manual. And I really like it, not just because it's written well and it helps the student and the type of questions, the post-lab questions that are there, but more importantly, the answers to these questions are nowhere to be found. So students were not able to find the answers at all, and they just had to think to answer or to complete the post-lab assignment. What I have not done is that once we transitioned in the spring to fully online, the students did not keep notebooks anymore. However, I think in the fall semester, when we do those few online laboratories, I plan to ask the student to keep the notebooks for all these labs as well, because after all, some of the learning outcomes regarding maintaining a lab notebook are completed outside the lab. So in the fall, I'm going to ask students to fill out and enter the title, objective, date, and the typical, and chemical reactions when appropriate, or reagent table and safety considerations when, depending on the lab. So this is what we've done in the spring. In the fall, can we move to the next slide, please? Thanks, Zoe. So in the fall, we're going to have a mixture of synchronous, asynchronous, as well as face-to-face time in the lab. So we don't have an exact plan yet, but we are using the learning outcomes that you see on the screen. And these are drafted by Nancy, my colleague. She used the Ohio Department of Higher Education site, the TAG guidelines, the ACS Committee on Professional Training, and a couple of other resources to draft the main learning outcomes that we want to use for the laboratory. And based on these, we're going to select experiments for the students to do. Now, again, we're going to operate at a 50% capacity. So pre-COVID, our capacity for lab is between 20 to 24, depending on the space. I teach at the Eastern Campus of Tri-C. My lab space pre-COVID was 24. After COVID, we're going to operate at 50% capacity, which is 12. Not all the labs were actually going to have 12. In some sessions, we're going to split the students into two groups with 6 at a time. So we're going to only have, most of the time, 6 students at a time. Each student will be assigned a fume hood, and for the whole semester. We've talked about preparing all the lab supplies and chemicals inside the hood for every student, so they don't share any of that chemicals or supplies. We're going to select the experiment to maximize the techniques and to, of course, to hit all of our learning outcomes. We're going to have the students between 6 to 7 times, or 6 to 7 sessions. So we feel that we're going to be able to achieve these learning outcomes and have at least a couple of syntheses in addition to learning all the techniques. In terms of assessment, what I have done is Blackboard quizzes and Blackboard testing. And just like Chris shared before, my students found answers on Chegg. So I've decided to write all the questions on my own. It was extremely time consuming, but I feel that it was much more successful. I used the time limit. This was a big factor. We also prohibited backtracking, so students cannot go back and change answers. And then for the final, I gave them a take-home exam. And again, the students, I guess, did not know how it worked. So I think that it worked well for my group of students. I agree that it is important to have them write rather than just do multiple choice. And after all, I think our students need to learn writing skills. So I'm also going to be doing a lot more writing questions rather than just multiple choice. Our students don't have access to ChemDraw or SciFinder, but we have a couple of free resources. One of them is ChemSketch, which is an app that students can download for free. I also have that on my computer at home, and it's very smooth. There's also another virtual model kit that is free for students. It's called ChemMagic, where students can see the three-dimensional molecules in three-dimensional. It's a virtual model kit. They can build different molecules virtually. Okay, last slide, please. All right, so this is the last slide I have. I just wanted to share with the group that I've recently attended a webinar by the ECS on teaching remotely for chemistry, and it provided towards the end of the webinar a list of resources organized into 6 categories. The list is not comprehensive, although it feels like it because it's 5 pages long. But I found a lot of these resources pretty useful. Some of them technological tools in assessment. Some of them are instructional tools. So I just wanted to share that with you. The link is down there, and I know you can't copy that, but I can share the presentation with everybody if you may find something useful. Okay, thank you very much for listening, and I'm happy to answer any questions.
Well, thank you very much, Heidi. That was great.
Thank you.
So maybe the thing to do next then is if anybody has any questions or discussion that relate to what either Heidi has spoken about or what Noel and Chris spoke about, maybe that could get us started with some broader discussion.
I'd like to just commend Heidi for the not only the emphasis on the writing, but also the I thought it was really sublime to use Google and YouTube to find videos that aren't right and have that be a part of the actual experience. I think that that's a very rich treasure trove of very high level things that students could be thinking about. So bravo to that.
Thank you. You know, we have to work with what we have. We're a very small institution, and we have a small group of students, so it worked for us. But thank you.
I think one thing that came up with both presentations, and something that as I taught a summer class, I sort of wrestled with, was this idea of proctoring assessments or finding ways around so that you don't proctor an assessment. And in my own approach, I only had a fairly small summer class with 25 students. And so I used Proctorio as a proctoring tool, but frankly, it was a bit of a nightmare. So I was wondering if perhaps others might also talk about what sorts of approaches they've used for assessments so that you can avoid the elephant in the room, which is this really the student's work, or are they simply having their friend do it or copying it from Chegg, as was pointed out. So maybe that's a point of discussion that others might have opinions on.
If you like, I can jump in on that. We did a little bit of that out at UC Blue Ash. Now, we've got small class sizes, so I was only working with, I think I had maybe 30 students there. But what I did is I had them all in WebEx, had them turn on their webcam so that way I could monitor them, and then it was a timed exam, and then they had to submit it at the end. It's still imperfect at the end of the day, but it was, in some respects, about the best that I could do on that quick turnaround in that case. And it worked out decently well. Their grades didn't change all that much from beforehand. So it seemed to work out. Unfortunately, I didn't have a chance to try it this summer to find out how it went how it would go more broadly. Oh, sorry, this is Matt DiMatteo from UC Blue Ash College.
Thanks, Matt.
I apologize.
No problem. Phil, I think you're muted if you were trying to say something.
Yeah, okay. Phil Roskis at Lakeland Community College. I was late. I couldn't get into the program quickly, so I've been here about 10 minutes. But anyway, I'm still teaching. I have to give a final exam in Intro to Organic this summer. I'm giving it tomorrow, but I gave a couple of quizzes, if you will, and we graded them right afterwards. I trusted them. I told them that they must be honest. They're professionals, but they graded their own quiz and they turned in their papers and online and the results. So I could see their quizzes, but they graded them. So they got I called it instant gratification. They liked it, and they're doing quite well. But anyway, it's a little bit, I'm having a rough time examining. It isn't fun at all for anyone. But I do that, and then of course they're final. They will send it to me. I don't know what you could do in terms of. I heard you turn on your cameras and keep an eye on them, real quick, and then I'll shut up. I got a couple students that do not have cameras available. They tell me. I don't know what that means. So. And they don't have printers available, for printing stuff out sometimes. So we're working at it. Anyway, I shut up.
Thanks, Phil.
Phil, I ran into all those problems myself. I also taught a lecture course in the spring. And I don't know, I think my theme has been like, do whatever I can to give my students a chance to show what they've learned or not. And I had students just write answers on a blank piece of paper for their exam. I also experimented with different amounts of time. I think as short as you can make it without being a jerk is probably the optimum. But yeah, I know. I think the access to a tablet or a computer that's good enough or internet that's fast enough, I think all those things are, even if it's one person in your class, that's still somebody who's super frustrated. So that, those same challenges are stuff that I have worried about and still worry about.
Yeah, I agree. And I try to make them feel comfortable. I keep telling them that it is their career and they have to be honest. They have to learn all they can so they can be successful as they go on. Now, this was intro to organic. In the fall, I got the big girls and boys in the organic. But again, I put a lot on them as learners and people trying to get ahead. And I asked them lots of questions. I used true and false, multiple choice, write it out, write in the formulas. Organic is tough because you have to write all these formulas, and for them to send them back sometimes is a bit of a challenge. Sorry.
When you have them back, are you having that? One of the things that I did with my class is that sorry, this is Matt DiMatteo again. I apologize. One of the things that I had them do was I had them all download a scanning app so that way they could write their answers on a piece of paper, scan them into one PDF document, and then they could upload that through Canvas. So I could then grade that using the I can't remember what it's called, but the thing that allows you to give feedback on directly on Canvas there. It's a little time consuming at the end of the day, but it works out. That did mean that I had to allocate about an extra 10 minutes for them to actually do that scanning and uploading in terms of my time. That seemed to help. Yeah, Cam Scanner was the one that I used. It seemed to work out the best.
Yeah, Cam Scanner just blows some people's minds. Like, what? My phone can do that? I also agree, Matt, that feeling out that right amount of additional time, I'm sure that my students use their tech and upload time to work harder on the problem, but that's not a fake thing either. It does take some time. Everybody, just because these are young students for the most part, does not mean that they are tech geniuses.
Yeah, that's true. Agreed.
Yeah, the biggest draw. Oh, sorry. Go ahead. Sorry, Chris, I saw you had something. Go ahead.
We even face unique challenges at Ohio State because of the international population of students. Even though we had a large question bank of different types of questions that were displayed within our course management system, certain students in certain countries couldn't see the images because their internet browsers and IP addresses restricted those images from being displayed. And so there's going to be different types of problems for everybody. We had to send those students PDF versions of the exams that they then resent back to us in some portion. And so a lot of unique experiences with online assessment.
One of the things in talking to a friend of mine who's in instructional design was that using more but smaller assessments was probably the way to go in this kind of environment. So I actually doubled the number of in-semester assessments in my summer class. It was a bit of a problem in that what I was aiming for was a 25-minute mini exam, and what it turned into usually was a 50-minute mini exam with time involved in convincing the Proctorio service that this was really the student they said they were, and probably in some cases 10, 15, 20 minutes to get into the exam, and then using Genius Scan or some other phone app building the PDF to submit. I did these on paper, or had the students do them on paper. So it did cost a lot of extra time. I probably lost 3 lectures worth of time due to that extra assessment time. But one of the worries about long assessments is it's much easier then to seek help, particularly in places like Chegg. There's a delay time in Chegg replying, and if you use shorter assessments, then it's more difficult for students to cheat. But certainly the approach I used was definitely not optimal because of the amount of time that it took. And the frustration, frankly, because there were probably in each exam a couple of people who just could never get into Proctorio, and I'd actually have to send them a PDF of the exam by email and say, please don't cheat. And as long as it was different people every time, I figured nobody was gaming the system, so I let that go. I had a question for Noel and Chris about this JSME editor, which looks like a pretty cool way of integrating structure drawing within the learning management system. Do you know if that tool is usable across various platforms, such as Blackboard and the like?
As long as your learning management system can accommodate an iframe in the HTML coding for questions, it can be used.
Okay. That seems like a good compromise.
Say it again, I didn't hear you.
Sorry, it seems like a good compromise approach where instead of using the hand-drawn exams, having them draw on the screen where the proctoring services work best when everything is on the computer as opposed to when they're writing on a piece of paper.
Yeah, for
Chris, can I?
large volume of students, it did work well.
This is Nancy Doherty from Tri-C. Chris, can I ask another question about that editor? How strict was it in terms of what it would accept for answers? Did you have to come up with multiple smile strings, for example, or if they used, you know, if they drew an SP hybridized carbon that was bent, would it accept that?
It does not grade the shape that they brought at, as long as the connectivity is correct.
Okay, so it's like the ChemDraw grading.
Yes. You have to go, we did put multiple smile strings in for certain structures. If you draw perhaps an aldehyde hydrogen in,
got it.
That's a different smile string than one that is fully skeletal for an aldehyde. So you just have to, we use it so much in our pre-labs and post-labs, our students have a practice resource where they can go through and get feedback on redrawing molecules correctly. I would recommend that if you're going to use it, make a resource where they can go and draw 20 molecules and get feedback if they draw them the correct way using the editor.
So Nancy, one of the things about smile strings is that there are some different ways to create them, but within the same code, they tend to be consistent. So ChemDraw smiles always are correct with ChemDraw smiles. The same with JSME, but sometimes there are differences between JSME and ChemDraw, for example. So as long as you're consistent in what you use and what your students use, then you'll be okay, along with the extras that Chris pointed out, where you have to just think about whether you drew the hydrogen in for an aldehyde or not.
I can add to that I had an email exchange with Peter Ertl a few years ago, and it will handle stereochemistry of a single stereo center, but you may have to generate two different answers because it even if it's a dash or a wedge and you've drawn it correctly, I think that depending on which type of smiles generator you're using, it does like make it have two different answers. I know for a fact that diastereomers having two stereo centers, that's a huge pain in the ass. Pardon the French, but it's a thing.
Thank you so much. That you just saved me hours of playing around.
Was that French? Was that French?
It's one of the more mild terms in my vocabulary.
Yes, it's the same as French toast. This is Roscus at Lakeland. It's so crazy. I know. I have to say that, yeah, it's a lot of work. I have been sending them, just real quick, I've been sending them notes because I sit here, I write out my notes, and then I send them to them on Blackboard. They get the notes for each class, we date them, we go through them, and then that's what they're responsible for. I go over the notes with them. They seem to like it in this intro course. And they did well, and they got all the notes. But with stereochemistry, that was kind of tough. And but one of the assignments I give them, and they have to go to a place, they have to get large marshmallows and little colored marshmallows and toothpicks. And they have to make this. And we use our hands a lot for reflections. I mean, you have to be so darn creative. But it's a challenge. And that's why I do my course on WebEx rather than the alternative, because I can meet with them and we can signal one another. But anyway, yeah, it's tough. I'm sorry. It's just going to be tough. And it ain't going to get any better, is it? Ain't going to get any better.
Not anytime soon, no.
And we'd have to,
I had a question actually, maybe switching gears a little bit and talking about the lab course. And Heidi had mentioned that each student will have all of the resources they need for their experiments within their hood. And I think Noel, perhaps it was you, was talking about using an adjacent hood for a lot of the supplies. But what about things like balancers and spectrometers and the like? Are the students sharing those resources still? And if so, how are you managing to keep safety as a priority as they do that?
We definitely have a couple ideas. We don't obviously have enough analytical balances to put 10 in each room times 6. But moving, so our floor plan has this this balance room in the center, which is pretty much the perfect place to catch COVID. So I think de-emphasizing that room entirely, moving balances at least to a having several areas in that 10-person space with an understanding of, keeping physical distancing. But there are other ways to do it too, but I think that is tough. And the more expensive the piece of equipment, the less of them we have too. So infrared, I'm not sure what we're going to do about the IR.
Right. One of my colleagues, Chris Fank, had been looking on Amazon for inexpensive balances. And Chris, I know you're on the call. Can you remember how much they were per balance? The 2 decimal place balances, I believe. Maybe he's not at his computer. As I recall, you mentioned...
I'm here, Paul.
Okay.
It just took me a second. Sorry.
No.
We looked at a couple different options. One just has simple batteries, AAAs, which we didn't want to have to swap those out all the time. So we looked for ones that had an actual power adapter. And we were able to find balances that had a 600-gram capacity that read to 2 decimal places, and they were $30 a piece.
So with that sort of pricing, it's reasonably practical to give each student their own balance.
The one thing that we do not want to do is keep moving things around, like on a daily or weekly basis. Like the value of having a fancy balance is lost if nobody's calibrating it or it's getting, damaged or something. So that's a really good find.
You have to have vodka, 190 proof, and a spritzer by every balance.
And a shot glass.
Well, no, you got to have this spritzer thing. I tell you, I swear that this, for $18, you get this pure alcohol. It's legal, and you just spray it. I spray everything. But can I just?
We almost do a flight attendant type system, like where you have a service light.
Yes, you
have magnets on the hood where you could put a magnet up on your hood and say, like, I need to use something. So the TA can direct them to an area. We envision like one balance would serve 3 or 4 students. And so when you need to use it, you could put a little magnet up on your hood saying, like, I need to use this at some point. Your TA can direct me towards it.
Okay.
And honestly, if you think about the CDC guidelines, all of those guidelines for the distance between people is really intended for a location that's indoors, that's recirculated air. In all of our lab spaces, we have single pass air. So in reality, as long as they're wearing a mask, granted, you have to deal with the fogging of the goggles and other things like that. But in principle, as long as they keep their mask on, and they aren't like, touching their forehead or licking their fingers in the middle of lab, then the communal sharing of equipment will not be as problematic as many people think.
Are they allowed to leave the lab to use the restroom when needed? Is that a problem? Wash your hands before, after? I mean, that's a silly little thing, but that happens during a lab.
Yeah, we have planned that they would remove their disposable mask, go to the bathroom, come back, put a new mask on, re-sanitize, and put new gloves on and proceed. So yeah, we have ideas in place for them to leave if they need to.
Okay, now I'm being very naive here. Phil Roskis at Lakeland. We were not allowed to go to the lab this summer for organic or anything. But this fall, I think you're planning to meet for laboratories, or some of the laboratories. Are most of you planning to have your students do labs hands-on?
We're planning a 50%, every other week they would come for lab, and then certain weeks they would do online labs. So about half of the labs would be in person.
Okay, some of the main labs might be in place, so you get the techniques of recrystallization, fractional distillation, a couple reactions, and again, chromatographs, the spectrometers, IR, NMR. Yeah. So you don't plan to be in lab every week, right? Is that kind of what you're saying? Do some of them remotely or prep remotely?
So Phil, this is Owen Brathwaite also from Tri-C. I don't teach, I'm the associate dean. And yes. So what I am allowing, not just me, but what the associate deans have agreed on is that the faculty will decide the number of labs that they want to cover in person. It's not on the schedule. It will be part of their syllabi. And so Nancy and Heidi can then decide, I want to do just these 5 labs for the entire semester that fulfill their mission and their goal. I am not going to oversee it. They dictate what labs they want to do in person.
Absolutely.
And when, and what the date and time. And all this has to be done before Thanksgiving.
Now, the other problem we're going to face is that some students will not want to come on campus. In other words, they will not want to come to the laboratory and work with others.
Yes.
I don't know.
And again, we leave the instructor to regulate that. If there's a student that says, I don't want to come on campus because of a existing condition or whatever they specify, we leave the instructors to regulate that. The deans are not going to oversee the day-to-day pieces. We have trusted our faculty to manage so I haven't met yet with Nancy. Like you, we were not allowed on the campus, so Nancy and I have not done I did a walkthrough with our compliance department, but I haven't done a walkthrough with Nancy just yet. We are planning that when I'm back from vacation. And she is going to become more than a chemistry instructor. Since we don't have TAs, she's going to be the TA, the director of the flow of traffic within one lab. So it's going to be pretty demanding for instructors to monitor student behavior and keep them safe.
Well, the other thing is just a thought. Many of my students, they know one another. They get to know one another. And we may end up having a student taking some videos of if they can't come to the lab, we can take videos of the equipment and the setup and maybe, enough so they get the idea, even though they're not going to get hands-on, at least keep doing the lab at their college or university.
Yes.
That?
That's a brilliant idea. And we've also working on that. We had a videographer who would have done that for us, but unfortunately he was terminated because he was a part-timer.
Yes.
So yeah.
Yes.
I think that one of the challenges here, we're also, if we're doing face-to-face, we're dropping down to 9 students per section instead of 20. But if you try to do things on an every other week basis so that you can have 18 students in a section, and how do you manage the at-home piece of this? It seems that you need double the number of TAs in order to be able to provide an appropriate experience. Because I think, as Noel or Chris pointed out, that idea of interaction with a person is so important, and we don't want to be just sending students home to do things on their own. It seems to me that there ought to be some structured, supervised, or interactive activity, even if they're not in the laboratory. So what sort of ideas are available that people have thought up for how you deal with that problem of basically needing double the number of teaching assistants if you're to provide this kind of experience? Or am I missing something?
Our numbers are not essentially double because we have full-time staff that are TAs that work 40+ hours a week. And so your entire section will come in and split up over 2 rooms. So it's 10 per section. So you're there with your group of 20. You have a staff person helping you during the day with the other 10 of the people, and you're with 10 of the people. So when you're off and you can be online with your students.
Got it. And when you have them in 2 separate rooms, you have a second person, a safety person that would be available. So there's always some supervision in each room.
Correct.
Yeah.
This is Heidi, and we also doubled the number of sections, Paul, so that students would come every week. Because otherwise, if they come every other week, we would have to create some online activity for them the week they're not on campus.
Yes.
And the flow and the structure of the content won't be adequate if we do that, and the learning won't be adequate. But I also wanted to ask another question. Did anybody think of if a student get infected or got sick? Do we have a plan in place on how to handle that?
I say start Thanksgiving early.
So
that's good. Yeah, that's a really good concern, Heidi. I think that was Heidi.
Yes, that's right.
If this is Phil Roskus again, if there is even somewhere in another outside of chemistry, if there's an incident, it's going to cause a whole big jam up. They're going to, shut things down. I think they probably will. Don't you think they could shut us down?
Yeah.
And have to do everything off campus.
I will be extremely surprised if we're still on campus in mid-October. Maybe I'm a pessimist, but I think we only have 5,000 students coming back to campus for face-to-face classes. But even then, given the infection rates and the sort of silent infections that are going to be present among those 5,000, there's a good chance that there will be outbreaks on campus. And I'm not sure that there's a great deal we can do about it. We can do the best we can. That's really all we can do. But it wouldn't surprise me if we're unable to manage to get through the semester on campus.
Well, I think
we ran a lab this summer on campus. It's not a chemistry lab, it's a vet tech lab. 8 students, and so far all 8 students are still healthy. Good social distancing. The instructor, John Thomas, really controlled the students well. So that is sort of a slight model for us. What John has done, keeping the masks all long the students are in the laboratory. To enter the building, the student must bring their own mask into the building. You cannot, your temperature is checked at the door. Only one door was opened up to the campus. All other doors were locked, and traffic was regulated in the building. So I don't know exactly what we're going to do in the fall, but we are learning from that as a way to keeping students and the staff safe.
Just to read one of the comments in the chat, Marty Schindler pointed out that yesterday OEA recommended going fully remote for counties in the red. So I guess it may be a local area issue that will determine who has to move fully remote when.
To revisit the worry about students being ill, like this is because we play the game of numbers. It's like I'm not being sarcastic. Every day there was one of our students in the hospital for something, just on a normal, in normal life. So, we don't want students that have some sort of gastrointestinal disease or even a cold. Like, we don't want these people in class either. So we are working on a way to, have the student decide, like, yeah, I'm sick, I don't want to be around people, but I don't want to get behind. So can we give them some sort of assignment that covers the same topics as what would be happening in the lab? That's like one of our options that we're thinking about. Students are going to get COVID. Like, there's no way around that. I don't think it's us. Like, you're going to get COVID going to a party on Thursday night. So the students that end up being really out of it, even if they're hospitalized, we also have an idea for just a totally independent makeup assignment that would happen towards the end of the semester. So that's our best, our best guess right now of how to deal with those two things. But it just speaks back to the idea of flexibility. Like, if you don't plan ahead for flexibility, you're just going to be frustrated. So that's, I just have chosen I've chosen my crosses to die on. And being really rigid is not one of those things.
Right.
Oh, dear. Well, we say do the best you can, and we have to smile about it. Got to keep our smiles, or else it's going to be really bad. But the students have to realize that this is a challenging time, but they still have potential in their careers, and we are doing all we can to help them get information, coursework, experiences, so they can go on with their planned careers. We need doctors, dentists, pharmacists, nurses, PAs. We need people in these fields, engineers, chemists. We need them. And I keep expressing this to my students. Please hang in there. Study, be honest, be truthful. Everybody isn't an A. You don't have to be. Best you can, please. And stay with it. I don't know. Philosophy.
I've only been doing this for like 11 years. So, I'm on the younger side maybe of the experience pool. But I find, to just really like reiterate what you said, Phil, like, chemistry is one thing. I can teach chemistry, but they're not going to learn it if we don't care about them, and we don't give people the benefit of the doubt. One of the other things, like, COAM stuff or academic misconduct, the day that I decided that I was not Columbo or whatever, like, I am not a FBI investigator. It's like, okay, cool. Like, I don't have to worry about that now. Like, I don't know. There's just so much of the social aspect. I could not agree with you more. Like, getting them through this and making good thinkers is so important. But like, they're not going to make it if they see us as a barrier to that too. I don't know. Now I'm just, that's my philosophy. But
we cannot be. Sometimes we get so rigid in our teaching, and we have to step back and say, hey, you can't do that, because these students, they have families and friends that are ill. They have family and friends that are going through things. And, it's been very frustrating. And I've learned that since the spring and this summer, and I'm preparing for fall. The same thing that you're saying. It's going to be, we have to be a little different in our philosophy and get them as much chemistry and science as we can get them under the circumstances. And we tell them they got to play the role of the dedicated student. Stay with us, darn it.
That's right. So we have maybe 10 minutes left, and so there's quite a lot of people on the call that haven't had a chance to say anything yet, and so I don't know if there's anybody that hasn't yet had a chance to voice their experiences or their questions. It would be good to hear from you.
Paul, it looks like in the chat, somebody asked about students collaborating in small groups for organic chemistry problems in synchronous class sessions.
Thank you, Zoe.
There are ways in Zoom, if you have access to Zoom, where they can do breakout sessions. So you can have an entire class together, then you can essentially assign them to 4 or 5 breakout rooms. And there's even a whiteboard that they can use in Zoom. Or one of the things I know our guided students have done is essentially to go in there twice, once on their computer and maybe once on their phone or once on their iPad, and then use their phone as a document camera. So then they can essentially draw things and share with each other. So I think you can do that with many of the different video capacities, whether it's a WebEx or a Zoom, depending on what the technologies are.
And certainly within Blackboard Collaborate, which is part of the Blackboard platform, that works fairly well. So yes, I think that's probably available in a lot of the different platforms. So yeah, that's a good idea.
Yeah, the challenge that I keep running into though with this is how to get them to do it in a fairly efficient way, right? No matter what I do, it seems like it takes quite a bit of time for them to get those images back and forth to one another. And that's where I'm struggling, because there's a huge lag then, and that means that's a lot less that we can get through during a class session. And that's where, so like breakout sessions are great, and I've looked into those. The hard part is that I can't figure out how they can, because the technology just isn't there for them to, for example, draw on their screen, unless they're one of the lucky few that have like an iPad with an Apple Pencil, or 2-in-1 with a pen or something like that. And so there's these extra steps that just slow that process down and make it hard for them to really collaborate effectively when I've been trying to do it.
I think the flip side of that, Matt, though, is that if you don't do something like that and you don't give them an opportunity to engage more actively, then it's quite easy for students to be logged in, but actually not present. So I think I sort of made the decision that it was okay that things would take a little bit longer and that maybe I get through a little bit less, just to try to make sure that they're actually intellectually engaged in class, because I think it's much harder to achieve that with the whole class in this remote setting than it is in a classroom.
This is Heidi. I just wanted to add that I think there is an annotate feature in Zoom and WebEx where the students, like I'm looking at WebEx, and there's this feature up there that if I enable it, every one of you can write on the screen. So the students can all write on the screen. There's also, if you use Zoom, if the student can share their screen, then they can use PowerPoint, and there's a pen tool on PowerPoint. And they don't really need an iPad to use the pen tool on PowerPoint. They can use their mouse on the regular desktop. But I believe there's an annotate feature on Zoom where the students can all write on the same screen at the same time.
Oh, wow.
Thank you. Just a real quickie, I have a good technical support group at Lakeland. And when I get into a jam, I call those people and they help me. So you may have that. You may have people in IT or whatever you call it, and they can give you some good hints. They can join you. I'm one of my main person. He's on my class list. And so he can come in and help us. Hey, we are scientists and we're really experimenting, aren't we? We are really.
All right. So we have just a couple of minutes left. So I just wondered if anybody had any last thoughts before we wrap up.
Just want to thank you, Paul, for your leadership over the years with all the work you've done with organic chemistry, the TAG group, and also your leadership with the OTM Natural Sciences faculty group. Our presenters today were wonderful. I love all of the participation. It's just been a joy for us to see the dedication of Ohio's faculty. You really do care about students, and we very much appreciate all of your good work. And Paul, I hope we get to see you along the way. I know you're going to be still working. You're just not going to be in those leadership roles for the state. So again, thank you. Thanks to everyone. Any other comments?
Well,
And Phil, I wish I had professors like you that would inspire me and tell me I didn't have to worry about always getting the right grade.
that's right. We don't drink in class. No.
I find that really refreshing. So thank you.
Well, thank you. And to the best to all of us, we are in tough thing. I'm starting my 51st year at Lakeland, and this is a real pain in the word that we heard earlier.
That's amazing. 51 years. Wow.
Yeah, 53.
Amazing.
And he's smiling and he's giving us good advice. My goodness, that's wonderful.
Just makes me think, Phil, I was 11 when you started. That's
Young buck, you. Whoa. Well, if you've got any ideas, whoever's commanding this session, thank you. Send us a note or two, and we'll try to stay in touch the best we can. But thank you.
Paula, is the plan to send access to this recording out to everybody who's on the call?
Yes, we can. Thank you.
That's great. Thank you. So Noel and Chris and Heidi, thanks ever so much for your presentations. I learned a lot from all of you about the approaches that you're using. Thanks everybody for joining. Appreciate it, and good luck in the fall.
Yes, thank you all very much.
Okay.
Be well.
Be safe,
Bye.
be smart, and enjoy the sunshine.
That's true. Bye-bye.
Bye.
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 Thank you.
Thank you.
Thank you. Thank you very much, everyone.